AP Calculus, section 3.2, page 5. And for this problem, we're asking to find a and b such that f of x is differentiable at x equals 2. Then we'll sketch a graph. So we have this piecewise defined function, and the first thing that we need to check for is continuity. At x equals 2. So again, f of 2 equals the limit as x approaches 2 of f of x. But because this is a piecewise defined function, we do need to check the limit from the left and from the right. So left side of 2 has to equal the limit as x approaches 2 from the right. Alright, this function evaluated at 2 gets plugged into here. That's 8 minus 1, 7. The limit as x approaches 2 from the left. 2 from the left into here. That gives us 2a plus b, because x is 2, so 2a plus b. And the limit as x approaches 2 from the right, plugging a 2 into here again, gives us a 7. So we have 2a plus b equals 7. All right, what that means for us, as long as we choose a and b to satisfy this, then the function will be continuous. So if a were 3 and b was 1, that would work. If a is 5 and b is negative 3, 2 times 5, 10 minus 3 equals 7, that would work. So there's multiple, many, infinitely many number of combinations that could make this work, that could make this function be continuous. So now we need to go on and make sure that the slope part matches. So we'll have to find f prime from the left side of 2, and then we'll have to make sure that that is equal to f prime from the right side of 2. F prime from the left side of 2. All right, left side of 2, right up here, let's look. Left side of 2, ax plus b, that's linear. And the slope up there is a. And we can say that because ax plus b is linear. Not so lucky on this piece. That's quadratic, so we are going to have to go through and do this limit as x approaches 2 of f of x minus f of 2 all over x minus 2. When we simplify here, coming at 2 from the right, lost my little superscript again. Let's see, f of x, that's 2x squared minus 1 minus f of 2, that's 7 all over x minus 2. And we have the limit as x approaches 2 from the right, 2x squared minus 8. Factoring here, we have the limit as x approaches 2 from the right, 2 times an x squared minus 4, which will factor into an x plus 2 and an x minus 2. And the x minus 2's will divide out. Sorry about the glare of the sun here. It's late afternoon. There's nothing I can do about it. I'm sorry. And we're left with the limit as x approaches 2 from the right of a 2 times an x plus 2. Subbing in, we get 8. All right, now again, we want this function to be differentiable. We're not trying to determine if it is differentiable. We want it to be for sure differentiable. That means this piece, the slope from the left, has to equal the slope from the right. We want these guys to be equal. which tells us then A equals 8. Once A equals 8, we can take that information and plug that in over here, and 2A plus B has to equal 7, so 2 times 8 plus B is 7, 16 plus B is 7, B is negative 9. All right, there we go. Let's see if I can move this. There we go, I got us out of the sun. All right, the last bit here is to sketch this graph. And plugging in that A and that B, let's see, we have AX plus B. So 8x minus 9 when x is less than 2, and 2x squared minus 1 when x is greater than 2. All right, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, here we go, plotting this. First off, this line. Y-intercept is negative 9. Thanks, brighter. Slope is 8, up 8 over 1, up 8. And I'm stopping it when x is 2, and that point is 2, 7. I did put a closed circle there because I know that the other piece is going to pick up right here. Okay, now the rest of this 2x squared minus 1, that's going to be a parabola. It opens upward. Vertex would have been down here at 0, negative 1. Let's see, so if we get this, we know it's going to start right there at 2, 7. Let's get the next point, 3. 2 times 9, 18 minus 1 would have been 17. 3, 17, way up here somewhere. And now, I am going to kind of draw this so you can tell the difference between them. This function is y equals 2x squared minus 1, I'm sorry, this piece. And this piece is y equals 8x minus 9. There is not a corner here. I've drawn it to show a corner just so you could tell the difference between them, but there is not a corner. Really, those two just kind of, they gradually flow one into the other. You can't even really tell the difference between them right in here at this point, 2, 7. Just for fun, if we kept following this line, then when x is 3, we would have been at, let's see, at 3, 15. So if we kept following that line, we would have been like right there. They're so close, it's hard to tell them apart. Again, not a corner. That line gradually changes. It's a very smooth change into that parabola. Okay, thank you very much. Please join me on page 6.